Hi, my name is CVR. Now we will discuss today about the vectors chapter. So, vectors. So, first, what is a scalar quantities and what is a vector quantities? First we will discuss. So, here what is a scalar? Suppose here this is a car, the length of a car is 4.5 meters. So here length represents a physical quantity and 4.5 meter represents that is a magnitude. So here this physical quantity and this is a magnitude. And similarly, so the mass of gold bar is 1 kg. So here mass is a physical quantity and 1 kg is a magnitude. And similarly, so here the time is 12.76 seconds. Here time is a physical quantity and 12.76 is a magnitude. So here their temperature is 36.8 degrees centigrade. So here temperature is a physical quantity and this 36.8 degrees centigrade is the magnitude. So first, what is a scalar quantity? A scalar quantity is a physical quantity that has only a magnitude. So what is a scalar quantity? Scalar quantity has only magnitude. There is no direction. So here examples of that scalar quantities is mass, length, time, temperature, volume and density. So these are the examples of the scalar quantities. Next, what is a vector? So here, so this is in California, in our graph, this is California and this is North Carolina. So the position of California from North Carolina is 3,600 kilometers. So in west, so here this position is a physical quantity and 3,600 kilometer is a magnitude and this is a direction, right? Next, so here displacement from USA to China is 11,600 kilometer in east. So here displacement is a physical quantity and 11,600 kilometer is a magnitude and east is a direction. So here a vector is a physical quantity that has both a magnitude and a direction, right? A vector is a physical quantity that has both magnitude and the direction. Examples of that is position, displacement, velocity, acceleration, momentum and force. Next, representation of a vector. How to represent a vector quantity? So here this is one line segment. Symbolically it is represented as AB bar. So here A is a tail and B is a head. This length of this represent that is a magnitude and here theta says the direction. Next, a representation of a vector. How to represent a vector quantity? So here they are also represented by a single capital letter with an arrow over it. So suppose this is A bar. So here first write capital letter A and write on the above A you write a bar. So that is A bar. And similarly this is a B bar vector is in this direction and here P bar vector is in this direction. Next, a representation of a vector. Some vector quantities are represented by their respective symbols with an arrow above it. Suppose here generally the position vector is represented by the symbol is R bar and velocity is represented by V bar and here force is represented by F bar. Next, types of vectors. On the basis of orientation, so here vectors are divided into first one parallel vectors. What are the parallel vectors? Two vectors are said to be parallel vectors if they have same direction. Suppose here this is A bar vector in this direction and B bar vector is also in the same direction. So here similarly this is P bar vector and this is a Q bar vector, but here magnitudes may be changed. This vector magnitude is suppose assume that is 10 and this vector magnitude is assume that is 5. So here magnitudes may change but the direction of the two vectors are same. Those vectors are called as a parallel vectors. Next, what is equal vectors? Two parallel vectors are said to be equal vectors if they have same magnitude. Suppose the two vectors are in the same direction and same magnitude also. So here this is A bar and B bar, both are equal vectors. When the both are equal vectors, both are same direction and both are having the same magnitude. Similarly, like this also, here also, this is a p bar is a one vector and q bar is another vector. So here the magnitude of p bar and q bar both are same and the direction is also same. Next, anti-parallel vectors. Two vectors are said to be anti-parallel vectors if they are in opposite directions. So here a bar vector is in this direction and b bar vector is in this direction. So in this case also magnitudes may be different. Suppose this a bar vector is 10 Newton and this b bar vector is 2 Newton. So here magnitudes may be different but the directions are opposite. Those vectors are called as anti-parallel vectors. So similarly here also p bar vector in this direction and q bar vector is in this direction. Next, negative vector. So here two anti-parallel vectors are said to be negative vectors if they have same magnitude. But here suppose this is a bar vector is in this direction and b bar vector is in this direction. So here both vectors are in the opposite direction but magnitudes remains the same. That is called a negative vector. So here a bar is equal to minus b bar. Both magnitude of a bar and b bar is same and the direction is opposite. Similarly here also p bar vector in this direction and q bar vector is also in this direction. Both are in the opposite direction but magnitudes both vectors are same. Then only these two vectors are called as negative vector. This is the negative vector. B bar is the negative vector of a bar. Or similarly here also p bar is the negative vector of q bar. Next, collinear vectors. Two vectors are said to be collinear vectors if they act along a same line. So here this a bar vector in this and b bar vector is in this direction. Both are acting in a same line. Not only about this direction, any direction. So here not only about here these two directions are in a same straight line. Then those vectors are called as a collinear vector. And here co-initial vector. So two or more vectors are said to be co-initial vectors if they have common initial point. So this is a bar and this. So here a bar initial point is this and this is the final point. So here also b bar, this is initial point and this is final point. Like that all initial points are same. So these vectors are called as co-initial vectors. And similarly next to coterminous vectors. Two or more vectors are said to be coterminous vectors if they have common terminal point. And these all vectors are ending what common point. That is called, those vectors are called as coterminous vectors. Next, what is a coplanar vectors? So coplanar vectors means suppose here the all vectors lying in a same plane, then those vectors are called as a coplanar vectors. So here three or more vectors are said to be coplanar vectors if they lie in the same plane. So here these all vectors a bar, b bar, c bar, d bar. So here coplanar vectors, all vectors lying in a same plane. Next, non-coplanar vectors. Three or more vectors are said to be non-coplanar vectors if they are distributed in space and all vectors are not lying in a same plane. So those vectors are represented in different planes. Suppose one vector is in xy plane and another vector in yz plane and some other vector in xz plane. Those vectors are called as a non-coplanar vectors. Next, types of vectors on the basis of effect. So here polar vectors. Vectors having straight line effect are called polar vectors. Suppose displacement that is acting in a one straight line and velocity acting in a straight line and acceleration is also, force is also. So vectors are having straight line effect. Those vectors are called as a polar vectors. Next, vectors are having rotational effect are called axial vectors. And that vectors are acting in the rotational effect. So here angular momentum and angular velocity, angular acceleration, torque, these are all called rotational vectors or axial vectors. Next, vector addition, geometrical method, how to add two vector quantities. So here this is, suppose this is a triangle. So what is the triangle law? Suppose this is a bar vector and this is a bar vector and this is a b bar vector. So here this c bar in the reverse order. Suppose here a bar in this direction and b bar in this direction. This c bar is incomplete side of the triangle in the reverse order. Suppose here A bar in this direction, B bar in this direction, C bar is in this direction. That is the resultant of this A bar vector and B bar vector. So here, this is suppose Egypt. From Egypt to Yemen, this vector A bar is in this direction. From Yemen to Iran, this vector is in this direction. So here, this from Egypt to Iran, this is the direction of the resultant of this A bar vector and B bar vector. So here C bar is equal to A bar plus B bar. This is called what we call as triangle law. Next, parallelogram law. So here, what is the parallelogram? So this is A bar vector and this is B bar vector. So here if you construct a one parallelogram, because this B bar, you construct here, you draw here parallel line to B bar and you draw parallel line to A bar. So this diagonal of this parallelogram represents the resultant of A bar and B bar, means the summation of A bar and B bar is the diagonal of the parallelogram. So here C bar is equal to A bar plus B bar. Suppose this is a pulley system. So here this vector A bar is in this direction, this vector B bar is in this direction. Now here this is A bar and this is B bar. The resultant of these two vectors is acting in a diagonal. So that is a C bar vector. Next, similarly, like polygon law. So here we can add polygon law more than the two vectors. So here what is polygon law? Adding more than two vectors. Suppose here this A bar vector in this direction, B bar vector, C bar vector, D bar vector. So here write here A bar vector in this direction and put the second vector tile is at the head of the first vector, like this. This is A bar, like this is B bar, and like put third vector tile at the second vector head, like this is C bar, and here this is D bar. And the incomplete side of this polygon, this is suppose A bar, B bar, C bar, D bar. The incomplete side is in the reverse order, gives the resultant of these all vectors like D bar is equal to A bar plus B bar plus C bar plus D bar. This is the polygon law. Now, commutative property. What is the commutative property? Suppose this is A bar and this is B bar. So, C bar is equal to A bar plus B bar. And similarly, so put here A bar is in this direction only and here this is B bar. B bar plus A bar is equal to C bar and A bar plus B bar is equal to C bar. So, here therefore, addition of vectors obey commutative law, like that is A bar plus B bar is equal to B bar plus A bar. This is a commutative property of addition. So, next associative property, like suppose this is A bar vector, this is A bar vector and this is B bar vector. This is the resultant of this A bar plus B bar. This is A bar plus B bar and this is C bar. So, here adding this A bar plus B bar plus C bar gives the D bar vector. So, here D bar is equal to A bar plus B bar plus C bar. And similarly, suppose this is B bar vector and this is C bar vector. B bar plus C bar is in this direction. That is the resultant of these two vectors B bar and C bar is this is B bar plus C bar and this is A bar. So here A bar plus B bar plus C bar is equal to D bar. So here therefore addition of vectors obey associative law. Next, subtraction of vectors. Suppose here this is A bar vector and this is B bar vector. This is A bar plus B bar. So here write A bar as it is. Here draw A bar like this direction. This is a B bar. What is the minus B bar? That is negative vector of B bar. So this is a B bar and negative vector is minus B bar is acting in this direction. This is minus B bar. This is A bar and this is minus B bar. The incomplete side of this triangle, that is this represents the resultant of this A bar vector and minus B bar vector, that is A bar minus B bar. Okay, the subtraction of B bar from vector A bar is defined as the addition of vector minus B bar to vector A bar, right? A bar minus B bar is nothing but A bar plus minus B bar. This is the subtraction of vectors. Now vector addition, analytical method. So here this is the magnitude of the resultant. So this is the parallelogram law of vector addition. This is very important. So entire so many in our physics, so many chapters this parallelogram law vectors is involved, right? Suppose here you draw, this is a P bar and this is a Q bar. P bar and Q bar are represented by the adjacent sides of a parallelogram. So this is P bar, this is Q bar, and here also you construct one, this is a P bar and this is also Q bar. So the resultant of this P bar and Q bar is the diagonal of this parallelogram, that is R bar. So here we construct a triangle here, and you draw one perpendicular, this is perpendicular, and you draw a dotted line, and here also you extended this P bar vector like in this direction. Now here in the triangle OCM triangle, OC square is equal to OM square plus MC square, like so OC square is equal to OM square plus MC square. OM is nothing but OA plus AM, OA plus AM whole square plus CM square. So this is the form of A plus B whole square, A square plus 2AB plus B square plus OA square plus 2 into OA into AM plus AM square plus CM square. Like so here in this triangle CAM, write cos theta. Cos theta is equal to what? Addition by hypotenuse. Cos theta is equal to AM by AC. AM is equal to AC into cos theta. So here now write OC square is equal to OA square plus 2 OA into AM is replaced by AC cos theta plus AC square. So here what is OA? OA is the magnitude of vector P bar, that is OA square is nothing but P square plus 2 into OA is P and AC is Q, because this magnitude is AC magnitude is nothing but OB magnitude, that is Q. So that is Q into cos theta plus AC square is Q square. So here R square is equal to P square plus Q square plus 2PQ cos theta. This is the magnitude of the resultant. R is equal to under root of P square plus Q square plus 2PQ cos theta. This is the magnitude. And what is the direction of this resultant vector? What is the direction? So here, if you say this angle, this alpha, if you say this angle alpha, then that is the direction of the resultant. So here, in triangle OCM triangle, tan alpha is equal to what? Opposite divided by adjacent. So that is CM divided by OM. CM divided by OM is nothing but OA plus AM, that is OA is P, that is, and again AC is Q. So tan alpha is equal to Q sin theta divided by P plus Q cos theta. So here in case of parallelogram law vector addition, suppose here this is P bar and this is Q bar, then the diagonal represents the resultant vector of P bar and Q bar, that is R bar is equal to P bar plus Q bar. What is the magnitude of this resultant? Root of P square plus Q square plus 2PQ cos theta. And what is the direction of the resultant? Tan alpha is equal to Q sin theta divided by P plus Q cos theta. You remember these standard results. And here this case one, vectors are, suppose these two vectors, P bar vector and Q bar vector are in the parallel. So P bar vector and Q bar vector both are in the same direction. Then we add these two vectors. And in our case, this is here, this theta is equal to 0 degrees. Substitute theta is equal to 0 degree in our resultant vector magnitude formula. Root of P square plus 2PQ cos 0 plus Q square, that is root of P plus Q whole square, that is P plus Q. So two vectors are in the same direction, then what is the magnitude of the resultant? That is P plus Q. What is the direction? Tan alpha is equal to Q sin here, that is 0. Q sin 0 divided by P plus Q cos 0. So here alpha is equal to 0 degrees. What is the meaning of alpha is equal to 0 degrees? So both are in this resultant is also in the same direction of either P bar or either Q bar. Next case 2, vectors are perpendicular direction. Suppose this vector P bar vector in this direction, Q bar vector is in this direction, both are perpendicular to each other. Then substitute theta is equal to 9 degrees in our resultant vector magnitude formula. R is equal to root of P square plus Q square. So here that is the resultant, and this is the direction. This is P bar, this is Q bar, this angle alpha. Tan alpha is equal to what? Q sin 90 degrees divided by P plus Q cos 90, that is Q by P. This is the direction of the resultant. Alpha is equal to tan inverse of Q by P. and here vectors are in the anti-parallel and theta is equal to 180 degrees. So p bar vector is in this direction and q bar vector is in this direction. Then in this case theta is equal to 180 degree. So what is the resultant? Root of p square plus q square plus 2pq cos 180. Cos 180 is how much? Cos 180 value is -1. So root of p minus q whole square. So r is equal to p minus q. So what is the direction? Again substitute here theta is 180 degree, then you will get tan alpha is equal to 0. Suppose if p bar vector is magnitude is greater than the q bar vector magnitude, then r is alpha is equal to 0 degree, and p vector magnitude is less than q vector magnitude, alpha is equal to 180 degree. Okay. If two vectors are in the opposite direction, see here these two vectors are in the like. Suppose here this is a p bar vector is in this direction and q bar vector is in this direction. Both vectors are in the opposite direction. If p bar vector magnitude is greater than the q bar vector magnitude, then what is the resultant? The resultant r is equal to p minus q. That magnitude is p minus q. Direction is towards p bar vector. So here this magnitude is greater than this magnitude, then the resultant r is equal to p minus q, that is towards p bar. And similarly, so if q bar vector magnitude is greater than the p bar vector magnitude, then r is equal to what? In this case r is equal to q minus p, that is towards q bar direction. This resultant is towards q bar direction. Suppose here example, one more example I will give. So here suppose this is a box of mass, this is mass m. I am applying 10 Newton force in this direction, and similarly I am applying 2 Newton force acting in this direction. Now in this case, what is this resultant? In this case, what is this resultant? Resultant, this is 10 Newton towards right and 2 Newton towards left. Then what is the resultant vector magnitude in this case? That is subtract 10 minus 2, that is equal to 8 Newton is the resultant that is acting towards 10 Newton force. And similarly, suppose here in this vector left towards left, that is 10 Newton force is acting, and towards the right, that is 3 Newton force is acting. Now in this case, what is the resultant vector magnitude? Because this magnitude is greater than this magnitude, then what is the resultant? Resultant is what? 10 minus 3. Resultant is 10 minus 3, that is acting towards left. So that is 7 Newton is the resultant vector magnitude. This is the case when both theta is equal to 180 degrees. So here when angle between the two vectors theta is equal to 0 degree, then what is the resultant vector magnitude? Resultant vector magnitude r is equal to p plus q. And when theta is equal to 180 degree, then what is the resultant vector magnitude? R is equal to p minus q. Theta is equal to 90 degree, then what is the resultant vector magnitude? R is equal to under root of p square plus q square. So here take one small example, like here p is equal to 4 Newton and q is equal to 3 Newton. In this case, suppose if theta is equal to 0 degree, what is the resultant vector magnitude? R is equal to 7 Newton. Like, and here theta is equal to 180 degree, then what is the R resultant? That is 4 minus 3, that is 1 Newton. And theta is equal to 90 degree, then what is the resultant? Under root of 4 square plus 3 square, that is root 25, that is 5 Newton. So here, whenever the angle theta changes, then the resultant vector magnitude is also changes. But this resultant has one maximum value and one minimum value. Whatever the angle between these two vectors, whether 0, 30, 90, 40, 100, whatever that angle, if the resultant vector has a one maximum value and one minimum value, what is that maximum value of the resultant is? That is p plus q, and minimum value of that resultant is P minus Q. So here resultant vector maximum value is P plus Q. When the resultant vector maximum value is P plus Q, when both vectors are in the same direction. When the resultant vector has a minimum value, that is P minus Q. So both are in the opposite direction. This is the resultant. So that's why this resultant value magnitude minimum value is P minus Q and maximum value is this resultant vector magnitude, like this is P plus Q. So here this is the maximum value of the resultant, this is the minimum value of the resultant. So here whatever the angle between the two vectors, the resultant vector magnitude lie in between P minus Q to P plus Q. That is not greater than P plus Q value and that is not less than P minus Q value. Suppose here in this case, put 4 is, this is 4 and this is 3, maximum value is how much? That is 7. Minimum value is how much? That is 1. That is not less than 1 Newton and that is not greater than 7 Newton. That is lie in between 1 and 7. Maybe 1, 1.1, 2, 3, 4, 5, 6, like that. So that is the resultant vector magnitude. These are the cases, okay? This theta is equal to 180 degrees is case. Next, suppose here we will discuss one more special case. Suppose special case, this case is also very much useful in our physics problems. Okay, so this here, this is the both vector magnitudes are same magnitude, like this is P and this is also P. Now in this case, what is the resultant vector magnitude? Angle between the two vectors is theta. Now in this case, what is the resultant vector magnitude? R is equal to under root P square. Q is nothing but P. P square plus Q square plus 2 into P into Q is nothing but P. That is cos theta. So that is root of 2P square plus 2P square cos theta. So here root of 2P square is common into 1 plus cos theta. What is the formula for 1 plus cos theta? That is R is equal to under root 2P square into 1 plus cos theta formula is what? That is 2 cos square theta by 2. 2 cos square theta by 2. That is 2P cos theta by 2. This is the magnitude of the resultant. So this magnitude is P and that magnitude is P. The angle between the two vectors is theta. Then the resultant vector magnitude R is equal to 2P cos theta by 2. Then what is the direction of this resultant? Suppose this resultant makes an angle. This resultant makes an angle alpha with this P bar vector. Now what is the direction of this resultant? Direction. We will discuss about the direction of this resultant. What is the formula for the direction? Formula for the direction is tan alpha is equal to what? That is tan alpha is equal to direction Q sin theta divided by P plus Q cos theta. Q is what? P. P sin theta divided by P plus P cos theta. So here P sin theta divided by P into 1 plus cos theta. PP cancel. So here sin theta formula is 2 sin theta by 2 cos theta by 2. And 1 plus cos theta formula is 2 cos square theta by 2. So here 2 cancel, cos theta by 2 cancel. That is tan theta by 2. So here tan alpha is equal to tan theta by 2. What is the value of alpha? Alpha is equal to theta by 2. So here this vector magnitude P and both vectors are magnitude remains same. Then the resultant vector magnitude is 2P cos theta by 2 and that resultant will angle bisect. So angle, this angle alpha is equal to theta by 2 and this is angle also alpha is equal, beta is equal to theta by 2. Okay, this is the special case. This is very important in our physics, right? Next, definition of the unit vector. What is unit vector? A unit vector is a vector that has a magnitude of exactly 1 and drawn in the direction of a given vector. So suppose this is vector, A bar is vector, and here this is the direction of the same vector direction of A bar, that is A cap. Unit vector indicated by the symbol is A cap. It lacks both dimensions and unit. Its only purpose is to specify a direction in space, that is the unit vector. So here a given vector can be expressed as a product of its magnitude and a unit vector. So any vector can be represented as like A bar is equal to its magnitude and a right unit vector along that particular direction. Suppose in the A bar direction, write A cap. So here A is what? A is the magnitude of vector A bar and A cap is a unit vector along A bar. So that is the unit vector. And here Cartesian unit vectors, generally we have some base quantities, like what this is also Cartesian unit vectors. This is standard unit vectors. Along x-axis we represent I cap, this is unit vector along x-axis, and similarly along y-axis this is unit vector along j cap, and similarly along z-axis that unit vector is k cap. Like similarly negative x-axis minus I cap, negative y-axis is minus j cap, and negative z-axis is minus k cap. These are the standard unit vector. These are also called as a base vectors. Next, resolution of a vector. So what is the resolution of a vector? It is the process of splitting a vector quantity into two or more vectors in such a way that their combined effect is same as that of the given vector. So this is the resolution of a vector. Suppose this is the A bar vector and this is x-axis and this is y-axis. You resolve this A bar vector along this axis and along this axis. This angle is theta. So here this is AX and this is AY, because this component of this A bar along x direction and this component along y direction is AY. So along x direction you will write into I cap, because that is unit vector along x direction. So that is AX is the magnitude of A bar along x direction into I cap, and similarly magnitude of y in the y direction is AY into j cap. So how to write what is the value of AX and what is the value of AY? So here this is a right angle triangle, and this right angle triangle, write sin theta. Sin theta is equal to what? Opposite divided by hypotenuse. Sin theta is equal to AY by A. AY is equal to A into sin theta. And similarly, cos theta is equal to what? AX adjacent divided by hypotenuse. Cos theta is equal to AX by A. So here AX is equal to A cos theta and AY is equal to A sin theta. So here the component of this A bar along x direction is A cos theta and along y direction is A sin theta. So here this is AX and this is AY and this is A bar. How to write A bar? A bar is equal to AX I cap plus AY j cap. What is the magnitude of that resultant? Under root of AX square plus AY square. And what is the direction? Tan theta is equal to AY by AX. So similarly, rectangular components in the 3D. In 3D vectors, you will write, suppose here along x direction is AX I cap, y direction is AY j cap, and z direction is that is AZ into k cap. So here in the 3D dimension, A bar, how to write A bar vector? AX I cap plus AY j cap plus AZ k cap. And here what is AX? AX is equal to A cos alpha. So this is A bar vector. This is in a plane. This is in a space. A bar vector is in a space. That A bar vector makes an angle alpha with x-axis in this case. So how to write cos alpha? AX divided by A. So AX is equal to A cos alpha. And similarly, this A bar vector makes an angle beta with y-axis. That is cos beta is equal to AY by A. That is AY is equal to A into cos beta. And similarly, that A bar vector makes an angle gamma with a z-axis. That is cos gamma is equal to AZ by A. So AZ is equal to A cos gamma. So here total A bar is equal to AXI cap plus AYJ cap plus AZK cap. The magnitude is root of AX square plus AY square plus AZ square. What is the direction? This direction alpha is what? The alpha is equal to cos inverse of AX by A, beta is equal to cos inverse of AY by A, and gamma is equal to cos inverse AZ by A. So here these cos alpha, cos beta, cos gamma are also called as a directional cosines. Suppose if a vector A bar makes an angle alpha with x-axis and beta with y-axis and gamma with z-axis, then cos alpha, cos beta, cos gamma are called as a directional cosines. So here the sum of the squares of the directional cosines is, that is, so here cos alpha, cos square alpha plus cos square beta, cos square alpha plus cos square beta plus cos square gamma is equal to how much? So that value, so that is we want to calculate. This value is, cos alpha is what? Ax divided by A whole square and ay divided by A whole square and az divided by A whole square. So that is equal to ax square by A square and ay square by A square and az square by A square. So here LCM is A square, that is ax square plus ay square plus az square. That is how much? This is A square, because we know that A bar is equal to, because A bar, vector A bar is equal to AXI cap plus AYJ cap plus AZK cap. Its magnitude is what? Mod A bar is equal to under root of AX square plus AY square plus AZ square. So this is A. So what is A square? A square is equal to AX square plus AY square plus AZ square. This value is nothing but A square divided by A square, that is equal to 1. So the sum of the squares of the directional cosines cos square alpha plus cos square beta plus cos square gamma is equal to 1. Now here, what is this value is how much? This value is 1. Similarly, what is the sin square alpha? Because here cos square alpha plus cos square beta plus cos square gamma is equal to 1. So here cos square alpha can be written as 1 minus sin square alpha plus 1 minus sin square beta plus 1 minus sin square gamma is equal to 1. 1 cancel. From this, sin square alpha plus sin square beta plus sin square gamma is equal to 1. So this is the sum of the squares of the sine value. So cos square, sum of the squares of the directional cosines is 1 and the sum of the squares of the sine is sin square alpha plus sin square beta plus sin square gamma is equal to 1. Now we will go to next, adding vectors by components. So here, just now before we studied triangle law, parallelogram law and polygon law. That is, suppose vector magnitudes are given. Suppose p bar vector magnitude is 4 and q bar vector magnitude is 3. Some angle is given. How to find the resultant vector magnitude? Like root of p square plus q square plus 2pq cos theta, that is the magnitude. And the direction is tan alpha is equal to q sin theta divided by p plus q cos theta. Suppose here in this case, if the vectors are given in terms of the rectangular components, like that is given in the I cap, j cap, k cap. And similarly here also b bar is also b cap bxi cap plus byj cap plus bzk cap. Now in this case, how to add these two vector quantities? R bar is equal to a bar plus b bar. Like first write a bar vector, then write b bar vector, write all I cap is common, ax plus bx into I cap and ay plus by into j cap plus az plus bz into k cap. So here this is the resultant vector. R bar is equal to ax plus bx into I cap plus ay plus by into j cap plus az plus bz into k cap. That is the addition, simple addition. A bar plus B bar. This is AX plus BX into I cap, AY plus BY into J cap plus AZ plus BZ into K cap. Okay, next multiplying vectors. So here multiplication of the vector quantities. So here multiplying a vector by a scalar. First we multiply a vector A bar by a scalar. Yes, suppose we get a one new vector. Suppose its magnitude is the product of the magnitude of A bar and the absolute value of S. Its direction is the same direction of A bar. If S is positive, if that multiplying quantity scalar quantity is a positive, then the direction of A bar, then the direction is in the same direction. If the multiplication factor is a negative, that direction is opposite to the direction of the A bar vector. Suppose here, this is A bar vector is in this direction, you multiplying 2, that is 2A bar in the same direction. So in this case, that multiplication factor is a positive value that is in the same direction. Suppose here multiplication factor is a negative. Suppose this is A bar vector in this direction, then multiplying -3. So minus 3 means that is acting towards opposite direction. So in this case, magnitude changes and the direction is opposite to the direction of the given A bar vector. This is what a multiplication of vector by a scalar. So in our physics, we use in our F is equal to ma. M is a mass, that mass is a multiplying factor, and A bar is a vector quantity. So here mass into acceleration is multiplied by, then you will get the some resultant, that is F bar, that is in the same direction of the A bar direction. So next here multiplying a vector by a vector. There are two ways to multiply a vector by a vector. The first way produces a scalar quantity and is also called as scalar product. The second way produces a vector quantity and called as a vector product, that is also called cross product. So we'll discuss about the dot product and cross product. So here first one we will discuss about the scalar product or dot product. So this is A bar vector and this is B bar vector, the angle between them is theta. So here A bar is this is a vector quantity. A bar is represents that is vector quantity here. A bar is represent what? Vector quantity. And similarly B bar is also represent a vector quantity. Means that is having a magnitude and that is having a direction. So this is also magnitude and the direction. Now angle between these two vectors is theta. Now you multiplying this A bar dot B bar. A bar dot B bar, in this case that is represents A bar is a one physical quantity and B bar is another physical quantity. Then A bar dot B bar represents third new physical quantity. That new physical quantity is a scalar quantity. That is A bar dot B bar is a scalar quantity. What is the magnitude of that A bar dot B bar? That is A magnitude of A bar into magnitude of B bar into cosine of angle between A bar and B bar, that is cos theta. So here A bar dot B bar is equal to AB cos theta. This is the scalar product. Example of the scalar product is, suppose here, suppose F bar is a one vector quantity, that is what? This is a force, this is a vector quantity, and S bar is this is also vector quantity, that is what? Displacement. So here F bar dot S bar represent new physical quantity, but that new physical quantity is a scalar quantity, that is represents work. So this is the application of the dot product. Okay, you hear A bar vector, B bar vector, A bar dot B bar is a third new physical quantity, that is a scalar quantity. Example, work done. So here W is equal to F bar dot S bar, and another example of that is power, instantaneous power, that is we will study about the work power energy chapter. So P is equal to F bar dot V bar, F into V into cos theta. So here also F bar is a vector and V bar is a vector. So F bar dot V bar represents third new physical quantity, that is instantaneous power P, that is a scalar quantity. So here geometrical meaning of scalar product. So here what is the geometrical meaning? A dot product, scalar product or dot product, both are same meaning. See, a dot product can be regarded as the product of two quantities. The magnitude of one of the vectors, the scalar component of the second vector along the direction of the first vector. This is discuss. See here, this is A bar dot B bar. A bar dot B bar is equal to A into B cos theta. That is, so this is A bar and this is B bar. This A bar dot B bar can be written as A into this component of B bar along this direction is B cos theta. So here A into component of B bar along this direction B cos theta, that is A into B cos theta, or this is B and this component A bar along this direction is what? A cos theta into B, that is A bar dot B bar. Next, properties of scalar product. Scalar product is based on commutative law because A bar dot B bar is equal to AB cos theta and B bar dot A bar is equal to BA cos theta. So A bar dot B bar is equal to B bar dot A bar. Scalar product obey distributive property, distributive law, distributive of addition. So A bar dot B bar plus C bar is equal to A bar dot B bar plus A bar dot C bar. So properties of scalar product, third one. So scalar product of two perpendicular vectors. This is also very important in the entrance exam point of view, like NEET and JEE. So here two vectors are perpendicular, then their dot product is equal to 0. A bar dot B bar is equal to A into B into cos 90, cos 90 is 0. So A bar dot B bar is equal to 0. Whenever two vectors are perpendicular or the two vectors are in the orthogonal vectors, then their dot product is equal to 0. And third one, next fourth one, scalar product of two parallel vectors, because theta is equal to 0 degree, then A bar dot B bar is equal to what? AB, that is the maximum value. The scalar product of two parallel vectors is a maximum, that value is positive because A bar dot B bar is equal to AB. And scalar product of two anti-parallel vectors, that is negative, that A bar dot B bar is equal to minus AB. A bar dot B bar, in the case of both vectors are in the same direction, A bar dot B bar is equal to AB. This is the maximum value, and this both are in the anti-parallel, A bar dot B bar is equal to minus AB. This is the minimum value. Next, the scalar product of a vector with itself, and that is A bar dot A bar. So A bar and A bar both are in the same direction. The angle between them is how much? That is 0 degree. So A bar dot A bar is equal to A into cos 0, that is A square. Next, very important, scalar product of two same unit vectors is 1, like I cap dot I cap or J cap dot J cap or K cap dot K cap, that value is magnitude of 1 into. So here, what is A bar dot B bar? AB cos theta. So here I cap magnitude is 1 and similarly I cap magnitude is 1 and cos 0, that is equal to 1, cos 0 1. So very important, I cap dot I cap is equal to 1 and J cap dot J cap is equal to 1 and K cap dot K cap is equal to 1. And similarly the two perpendicular vectors like I cap and J cap both are in the perpendicular vectors or orthogonal vectors. What is I cap dot J cap? So here what is the fundamental formula for A cap dot A bar dot B bar? That is A bar dot B bar is equal to magnitude of vector A bar into magnitude of vector B bar into cos theta. So in this case, I cap dot J cap, magnitude of I cap is 1 because that is unit vector, and similarly magnitude of J cap is also 1, and angle I cap dot J cap 90 degrees. So cos 90 degrees is how much? That is 0. So here I cap dot J cap or J cap dot K cap or K cap dot I cap, whatever, all except these two, except this, remaining all cases dot product of the two unit vectors is 0 degree. That is value, that is 0. I cap dot I cap 1 and I cap dot J cap, that is equal to 0. Now calculating scalar product using components. So here A bar vector is given, like in terms of the rectangular components are given. A bar is equal to ax I cap plus ay j cap plus az k cap, and B bar is equal to bx I cap plus by j cap plus bz k cap. Then how to calculate the dot product? A bar dot B bar. First write A bar vector, put dot, then write B bar vector. Now here multiply this into this, plus multiply this vector into this vector, plus multiply this vector into this vector. So like that you multiply ax bx into I cap dot I cap, ax by into I cap dot j cap, ax bz into I cap dot k cap. Like that you add, like that you will give. So here you know that I cap dot I cap is equal to 1, j cap dot j cap is equal to 1, and k cap dot k cap is equal to 1. Remaining all of that is equal to 0. So here a bar dot b bar is equal to ax bx plus ay by plus az bz. So whenever two vectors are given like this, how to calculate dot product? Just only multiply I cap quotient into I cap quotient plus j cap quotient into j cap quotient plus k cap quotient into k cap quotient. This is the multiplication of vectors in terms of the rectangular components. Or otherwise, if the vectors magnitudes are given and the angle between the two vectors is given, then what is the multiplication? A bar dot b bar is equal to what? That is ab cos theta. This is the multiplication when a bar and b bar are given in terms of I cap and j cap. This is the way of the multiplication of the two vectors, that is the dot product. Next, similarly, vector product. So here also a bar is a what? A bar represents a vector quantity. So here a bar represents a vector and b bar represents a vector. Now in this case, a bar cross b bar represents this. A bar cross b bar also represents a vector quantity. So vector quantity means what? That a bar vector has a bar cross b bar vector has a magnitude, and that a bar cross b bar vector has a direction. What is the a bar cross b bar vector magnitude? That is ab sin theta. So because a bar cross b bar is a vector quantity, you indicate the direction of a bar cross b bar also, that is n cap, where n cap is a unit vector in the direction of a bar cross b bar. See here once again, a bar is a vector and b bar is a vector. A bar cross b bar represents a third vector quantity, that is c bar. That is having c bar, that new vector, third vector is a magnitude, and that third vector is a direction. What is the magnitude of that third vector? ab sin theta. And what is the direction of a bar cross b bar? That direction a bar cross b bar vector is perpendicular to a bar vector, and that is perpendicular to b bar vector. That is the direction. So here a bar cross b bar vector direction. In this case, that is a bar cross b bar vector. In this case, a bar cross b bar vector is in the, that is downward direction. Put cross circle is the downward and a dot circle is the upward. So here b bar cross a bar vector is in the outward direction. Put a dot circle, because here a bar cross b bar vector and b bar cross a bar vector both are exactly opposite to each other. So here a bar cross b bar vector is in the downward direction and b bar cross a bar vector is in the upward direction. So next, so here suppose this is a bar, right hand rule. So for the, to determine the direction of the cross product, we use the right hand rule. So this is a bar, suppose assume this is a bar and this is b bar, like this is b bar, this is a bar, see this is a bar, and assume this is b bar. This a bar curls towards b bar. This thumb indicates the direction of a bar cross b bar, that is c bar. So this c bar is perpendicular to both vector a bar and vector b bar. So this is the right hand rule to determine the direction of the cross product. Next examples in our physics, like in our case of scalar product, I explained the work done. So here in case of the vector product, this is a torque, this will come in our rotation chapter, like R bar is a vector and F bar is a vector, and R bar cross F bar is a new vector quantity, that is the torque tau bar. That is a vector, that magnitude is Rf sin theta and the direction is, that is perpendicular to R bar and F bar. Similarly, like angular momentum also L bar is equal to R bar cross P bar. Now, geometrical meaning of the vector product. So here this is A bar and this is B bar. Then what is mod A? Mod means just only magnitude. Mod is only, that is A into B sin theta, AB sin theta. So here this is A and this is B. What this represents? B sin theta. This is B sin theta. So here this, in case of this parallelogram, this is a base and this is a height. So A into B sin theta. A into B sin theta represents what? That is, so this base, this is base into this is height. So that is area of the parallelogram. So mod A bar cross B bar represents what? Area of parallelogram made by the two vectors. So similarly here also, this is a base and this is height. What is the area of the parallelogram? Base and height. So this is B and this is A sin theta. So B into A sin theta, that is mod A bar cross B bar is equal to AB sin theta. Whenever A bar vector is given and B bar vector is given, how to calculate the area of the parallelogram is just only calculation of the cross product and magnitude of that is gives the area of the parallelogram. Similarly, next, properties of vector product. So here A bar cross B bar is equal to AB sin theta into n cap and B bar cross A bar is equal to BA sin theta into minus n cap, because A bar cross B bar vector and B bar cross A bar vector both are in the opposite direction. So that's why A bar cross B bar is not equal to B bar cross A bar. So here cross product does not obey the commutative property. So A bar cross B bar and B bar cross A bar is anti-commutative. And vector product is distributive over addition, like A bar cross B bar plus C bar is equal to A bar cross B bar plus A bar cross C bar. Next, the magnitude of the vector product of two perpendicular vectors is maximum, because mod A bar cross B bar is equal to AB into sin 90 degrees. Sin 90 is 1. So mod A bar cross B bar is equal to AB. And vector product of two parallel vectors, like angle between them is 0 degrees. So A bar cross B bar is equal to AB into sin 0 into n cap. So here A bar cross B bar is equal to 0 bar, because A bar is a vector and B bar is a vector. A bar cross B bar represents, that is a vector. So in this case, that vector is called as a null vector. A bar cross B bar is not equal to 0. So A bar cross B bar is equal to 0 bar, that is a null vector. Next, the vector product of two anti-parallel vectors is a, that is null vector, that is A bar cross B bar is equal to sin 180, that is 0 bar. And similarly, the vector product of a vector itself, that is A bar cross A bar is equal to 0 bar. In this case also theta is equal to 0 bar, theta is equal to 0 degree. Now, vector product of two same unit vectors, like I cap cross I cap. What is A bar cross B bar? A bar cross B bar is equal to AB sin theta. So A bar, we know the cross product definition. A bar cross B bar is equal to mod A bar cross B bar is equal to A into B into sin theta, where A is the magnitude of vector A bar and B is the magnitude of vector B bar. Now in this case, mod I cap cross I cap, 1 into sin 0. Sin 0 is, that is 0. Magnitude is 0, that vector is null vector. So I cap plus I cap, J cap plus J cap and K cap plus K cap is a 0 bar, that is null vector. Next, similarly, the vector product to different unit vector, like I cap cross J cap. I cap cross J cap is equal to K cap. So here I cap is a one vector and J cap is a one vector. I cap cross J cap vector is perpendicular to both vector I cap and vector j cap, that is k cap. So I cap plus j cap is equal to k cap. And similarly, j cap plus k cap is equal to I cap and k cap plus I cap is equal to j cap. This is one way to remember easiest method. Like that is, suppose here first you write, here you write I cap and here you write j cap and here you write k cap, like I cap cross j cap and j cap plus k cap and k cap plus I cap, like this, right hand. So I cap plus j cap is equal to k cap, j cap plus k cap is equal to I cap, k cap plus I cap is equal to j cap. Like in the reverse direction, so j cap plus I cap negative minus k cap and I cap plus k cap is equal to minus j cap, k cap plus j cap is equal to minus I cap, like that. This is the way to represent a direction of that cross product. Next, so like this is I cap, j cap, I cap plus j cap, k cap, j cap plus k cap, I cap, like that. So in case of a reverse, you will get the negative value. In case clockwise, then you will get the positive value. Anti-clockwise, you will get the negative value. So here and similarly, whenever the vectors are given in the rectangular forms, like I cap, j cap, k cap is given, how to calculate the cross product of the two vectors. So here, this is a bar is equal to ax I cap plus ay j cap plus az k cap, b bar is equal to bx I cap plus by j cap plus bz k cap. Then how to write a bar cross b bar? First write a bar cross, then write b bar. So here also, first ax I cap cross this b bar vector, right? Similarly, ay j cap cross this vector and az k cap cross this vector. So here again we multiply ax bx into I cap plus I cap, ax by into I cap plus j cap, ax bz into I cap plus k cap. So here I cap plus I cap, j cap plus j cap and k cap plus k cap, these values are 0. And remaining I cap plus j cap, that is k cap, j cap, like that, substitute these all values, then you will get the cross product. This is the a bar cross b bar. And one way of you do method, so this is the determinant method also, we can calculate the cross product. A bar cross b bar is equal to I cap. First you write I cap, so determinant method I will explain. So this determinant method, suppose here a bar is, so here a bar cross b bar is equal to, suppose this is I cap and this is j cap and this is k cap. Right here this is ax, ay and az, and here this is you write bx, by and bz. So here write first this is you write I cap into. So here you just only you draw line like this. So I cap you draw one line, horizontal line and vertical line. Then you write this determinant ay bz minus azby. Then again you write, first you write plus I cap, then again you write minus j cap. And similarly here also you draw in the j cap vertical line and horizontal line. Then what you will get, so here you write like in this j cap vertical line and horizontal line. Then you will get determinant ax bz minus az bx. And similarly you write plus k cap. So here that is ax by minus ay bx. So here first you write I cap, j cap, k cap and write a bar vector coefficients, I cap coefficient, j cap coefficient, k cap coefficient, and you write b bar vector coefficient bx, by, bz. First write I cap, you draw one line, vertical line and horizontal line at this I cap, I bar, I cap, this you draw these two lines, then you will get this determinant. That is I cap into ay bz minus AZ BY, then first plus I cap, then minus J cap, then plus K cap, minus J cap. And similarly for J cap also you write like this, you draw like this, AX BZ minus AZ BX, plus similarly for K cap also you draw like this, K cap also we draw like this, then you will get K cap into AX BY minus AY BX. So this is the cross product in the determinant form. So like this, okay? So okay, thank you. So if you like this entire video, please subscribe our channel. Thank you.